first thing we're going to do, guys, is we're going to recognize that parallelograms are made up of other shapes. What other shapes are they made up of? What are parallelograms made up of? Who remembers? That's it, Oratilwe. Hello, Oratilwe. Good, Leah, that's it. Hi, Leah. That's it, someone. They're made up of triangles. Now, not just triangles. What kind of triangles are we going to be looking at the moment? What kind of triangles do we want to prove? Not just equal triangles, Caitlin. What do we call them? We don't call them equal. We call them something triangles. We did it on Monday. So if you were here, you would have remembered what kind of triangles we started with. Not isosceles. I'll give you a hint. We started like this. We said in triangle, something, something, something. Ah, yes, that's it. Good, Caitlin. Excellent. Hi, Didi. Welcome. Good. We need to look for congruent triangles, right? And because we know that if we can break our question up into pieces, then the other pieces will come together. Hi, Chantel. It's amazing to see you guys this afternoon. All right, so the other small pieces will start to come together once we've figured out the congruent triangles. Hi, Sipokazi. Oh, no. All right, we're going to have this issue again. All right, teacher Nels, could you help out in the chat, please? Okay. All right, so I'm going to map them out like this, guys. I'm going to say in triangle ADB, and you guys will notice that I started at the corner and I went past the long side and then down the middle. So I'm going to go in triangle ADB and triangle, and then I started at the corner, so I need to start the corner and then go to the long side. CBD. There we go. So I'm going to look at triangle ABD and triangle CBD, right? And we're going to try and prove them congruent, because if they're congruent, then all the other sides will be equal to each other by default, because congruent means that everything is actually equal to the other. All right. So does anybody have anything they want to tell us about these? Now, remember, guys, let's start by thinking about the fact that ABCD is a parallelogram. What do we know about parallelograms? Let's start there. Who can give us a clue? No worries, Chifaro, welcome. We welcome you. You are part of the family. It's okay. Good. Not just B though, Didi. Think about properties of a parallelogram, guys. Good, good. I'm loving this. Excellent. Okay, let me start at the top. Amy says, two opposite angles are equal. Good. So we know that this angle and that angle must be equal to each other. And we know that this one and this one together must be equal to each other. Good. Opposite sides are also equal. Excellent. Oratilwe. So we know that these two sides must be equal to each other like that. That side and that side and that side and that side must be equal. Two pairs of equal sides. Good. Opposite sides are equal. Anything else? That's it, Oratilwe. Opposite sides are parallel. Sure. Excellent. Amazing stuff. Very, very good. All right, good. Aseza, yes, we can also say something about vertical angles as well. Okay, but at this point, we're going to take the information we've just put on the screen and we're going to do something about it. Yes, that's it, Amy. Diagonals bisect each other. Excellent. Okay, that's something we're going to have to remember for today's lesson. All right, Ivana, not so much that they are supplementary. Okay, they must be equal to each other. Okay, if you're saying they're supplementary, what you're talking about is the co-interior angles. All right, so if you say they're supplementary, what you mean is this angle plus this angle must be supplementary. That's because of co-interior angles. And the way we see that is because these two lines are parallel, AD and BC are parallel, right? So if I want to start this proof, I'm going to go, I know that AD and BC are equal to each other. AD is equal to BC. And the reason for this is because I know this is a property of a parallelogram. Properties of a palm. Okay. That's the first thing. Can anybody think of anything else that we could possibly look at here and try and prove? Anything else? There's always that one side. Yes, that's it, Sipokazi. That's what I was hoping to hear. Good. We know that BD is common. Good. BD is common. Now, Caitlin, your comment is not, it's not wrong. It's actually correct. It is 100% correct. Now, the only issue with saying that AC is equal to BD is you can't say that unless you've already proven that it's a rectangle. Because in the properties of a parallelogram, AC and BD are not equal. Okay, let me explain what I mean. A parallelogram usually looks like this, right? That's what a parallelogram means. And if this is called A, B, C, D, what you're telling me, Caitlin, is that this side is equal, the length of this thing is equal to the length of that thing. And that's not correct in a parallelogram. And since we know that it's going to be true for a rectangle, we can't use that property because we haven't proved that it's a rectangle yet. I hope that's making sense, Caitlin. Just give me a yes, ma'am, if that makes sense. If they said that it's a parallelogram, that property does not apply for a parallelogram. I mean, for a rectangle, it's only going to apply. Oh yeah, it doesn't apply for a parallelogram. It only applies for a rectangle. So we can't use it because what we're trying to prove is a rectangle. Okay, good, excellent, beautiful, Leah. Leah says that D2 is equal to B2 alternate angles, beautiful. But in this case, guys, I'm going to make it nice and easy. I'm just going to go AB and DC are equal to each other. I'm going to say AB is equal to DC. And the reason for that is also another property of a parallelogram. Now, we've already proven, guys, we've proven that these two triangles are congruent because we've got three sides. We've got three things. This is a side, this is a side, and this is a side. Now we can say, therefore, ABC, oh, so triangle ADB, oh, sorry, ADB, and you can, guys, you can put your reason for congruency in the chat for me. Is congruent to triangle CBD. Good, that's it, excellent. And our reason over here will be side, side, side. And now that we've proven this, now, Caitlin, you can say to me that AC, or yes, AC is equal to BD. Okay, now that we've proven this section. Oh, no, not me lying to you. I'm lying. Okay, we still have about one more step to do, but this is the correct thing that we've done over here. Right, so we know that it's side, excuse me, side, side, side. Now we know that each of the opposite angles in our triangles will then be equal to each other. So I can then say that angle A will be equal to which angle, guys? Angle A will be equal to angle C. Good. It will be equal to angle C. Excellent. We can say that. We can say angle A is equal to angle C, right? And it's because of the congruent triangles that we've just proved above. So you can say congruent triangles, or we can say CPCTC. Congruent properties of congruent triangles are congruent. I can also say that angle D is equal to angle. Good, that's it. Oratilwe, Retsepile, Amy, Caitlin, you guys are doing a great job. Good. Angle D is equal to angle B. But here is the kicker, guys. Here is the kicker. Because BD is common, that means that the next set of angles are going to be the same angle. Angle B is equal to angle D, right? So that's telling me the same thing twice. What that actually means, guys, is that this angle is equal to that angle, right? And if those two angles are equal to each other, then that automatically means, what about A and C? They need to be not common, Equal. That's it. They will also be equal. Good. So if D is equal to B, that means that angle A will also be equal to angle C. And this comes from the properties of a quadrilateral. What do we know about the interior angles of a quadrilateral, guys? Let me say interior angles of a quadrilateral. How much do they equal? Good. Ivana, be very careful. Not 180, not a triangle, a quadrilateral. Angles of a quad equal 360. Right. And if they're all equal to each other, what does that tell me about each of these angles? That each of these angles will be how much? I'm going to query here. Yes, that's it, Sipokazi. Well done, Lihle. Good. That means angle D is equal to angle B, which is equal to angle A, which is equal to angle C, and that is equal to 90 degrees. And that then is the one property of a triangle that we're looking for. A triangle, a rectangle that we're looking for. All right. So therefore, we can then say that ABCD is a rectangle. And the reason we are using here is the fact that the angles are, hi, Anotida, I will in just 2 seconds. All right, then we can say that the angles of a rectangle are, this is my reason, are 90 degrees. Okay, no worries, guys, welcome. All right, resharing. Okay, so for those of you who are still a little bit confused as to what to do, we always need to look at the question that they've given us, guys. Think about this. Okay, they've told us that ABCD is a parallelogram. If they tell us that ABCD is a parallelogram, can we use the properties of a parallelogram to prove for this triangle or for this rectangle? Yes or no? Yes, absolutely. And I see somebody asking, what does CPCTC stand for? It stands for congruent properties of congruent triangles are congruent. Okay, excellent. All right, I'm seeing you guys say yes. Yes, we can. We can use the properties of a parallelogram, but we need to prove that this thing is a rectangle. We're proving that it's a rectangle. So can we use the properties of a rectangle? Ooh, Chifaro, can I use the definition? Can I use the word car in the definition for car? Can I do that? If I'm trying to explain to you what a car is, can I use the word car in my explanation? No, it's not going to work. So because I want to prove that this is a rectangle, I cannot use the properties of a rectangle. I can only use the properties of a parallelogram. But we will remember that a rectangle is a palm. It's a parallelogram, guys. That's it. Yo, just on the money, that's it. All right, I see Caitlin asking, ma'am, what is CPCTC? It stands for congruent properties of congruent triangles are congruent. Now, let's say, for instance, we've got two triangles. Okay, if I have two triangles and they've given me an angle, an angle, an angle, and an angle, and they've given me a side and a side. This thing is congruent, yes? I can prove congruency here using AAS, right? Angle, angle, side. As soon as I've proved that these two things are congruent, what this tells me automatically is that this angle, this one over here, is also equal to that angle. And it also tells me that this side is equal to that side. And it also tells me that this side is equal to that side. So as soon as we've proved that two triangles are congruent, all the other sides and all the other angles then also become equal. Does that make sense? Give me a thumbs up if CPCTC makes sense. Didi, where did I lose you? I need to bring you back. Explain to me where I've lost you, my sweetie. Yes, ma'am.
Ma'am, like from the get-go, like I don't understand the whole topic, and like I go onto the website to rewatch the videos, but then I don't see you there. I see teacher Jane.
Oh, okay. All right. So they are. Okay, can we have this conversation just right after this class about Euclidean geometry? Okay.
Okay, ma'am.
The reason for this is because teacher Jen taught grade 10 last year, and she also taught this section. Okay, so they are different videos. Okay.
Okay. Yes, ma'am.
But we'll find out for you, and I'll let you know before the end of class. Okay. Today we're going to be doing analytical geometry. All right. We're going to be doing analytical geometry. Now, I'm going to ask you guys on a scale of 1 to 10, how comfortable are we with geometry, with analytical geometry? Okay, good. I'm seeing a couple of 5s. I'm seeing a lot of 10s, which is very helpful. Ayanda's like a solid 9. I don't want that solid. I don't want that 9 to be solid, Ayanda. It must be fluid so we can change it from a 9 to a 10. You know what I mean? We must get to a point where it's a 10. Okay. Oratile, I love to see it. Amkhalang is at an 11, and Amkhalang is also crying. I don't understand why we're crying. Austin says 5. That's perfectly fine. That is perfectly fine. All right. So the crux or the thing about analytical geometry that we need to be very, very cognizant of, guys, is if we do not know our formulas, and if we don't know how to use our formulas, analytical geometry is going to be difficult. Okay. This is angle of inclination. This is grade 10. This is grade 11. All right. So we don't have to worry about this one for now. All right. Don't stress about angles of inclination. It's grade 11 work. So don't stress. Okay. Princess is like, you at least, yeah, don't worry. I won't be asking questions about angle of inclination. Although, guys, have we seen this before? Have we seen tan before? Have we seen tan of theta before? Come on, guys. We have. So even if I did throw in a little bit of a, what is an inclination? You guys know what tan of theta is, and you'd know how to do it. Easy stuff. It would be so easy, guys. So it won't be difficult because you've already done SOHCAHTOA. So don't stress too much, guys. It's not that big a deal, I promise. It's perfectly fine. All right, guys. So take a screenshot of what you're seeing on the screen. We're going to jump. It's not. Princess, it's the easiest thing ever. It's so easy. Okay, it's not difficult. All right, take a screenshot. We're going to get started on today's lesson. Okay, we're going to look at this following question. All right. The first question says, in triangle ABC, A is 4 and 6, and we need to make sure that everything that they've written over here, they've given to us on our diagram. And if they haven't, we must add it. Okay. 5 seconds, 5 seconds. 5, 4, 3, 2, 1, let's go. Level up, level up, level up, level up, level up. Thanks, teacher Nels. I'll never be able to get over that. Okay, Oratile, that's all the time you get. That's all the time you get. All right, here we go. All right, so it says in triangle ABC, A is the point 4, 6. Good. Remember, this is the X coordinate and this is the Y coordinate. B is XY. Look at how they have not given us the value of the coordinates for XY. And they say that C is -4 and -6. All right, P, which is 5 and 1, is the midpoint of AB. So the point here, the midpoint, right? Yes, I know we do. I know we do, but that's something completely different. Okay. All right. So they've given us all the information that we need on our diagram. Now, I want us to, before we go, we're going to note that they haven't given us the values of X and Y. But what do we know about the value of X? Look at where X is placed, guys. would x be a positive or a negative coordinate? Look at where it is in relation to our picture. Would it be a positive or a negative coordinate? Good, let's say Pile, good. It's going to be positive. And what about my y? What about y? We know that this is going to be a positive coordinate and my y would be, that's it, Sipokazi, that's it, Rotepile, that's it, Leah. This would be a negative coordinate. The one thing we also know is that our coordinate for x will definitely be greater than 5 because 5 is the midpoint. So if we get an answer for x that's smaller than 5 or that is 5, we've definitely done something wrong. Okay, also with our y value. Okay, if our y value is positive and it's lying at like 0 or something like that, probably not. We probably haven't done this correctly. So we need to make sure that we're getting a good idea of the answers that we need to be getting here. All right, so the first question says, determine the coordinates of point B. Now, we don't know anything about the coordinates of point B, but they have told us that P is the midpoint of AB. Who remembers the midpoint formula? Any hands? Anybody want to give us the midpoint formula? Chifaro, yay, give us the midpoint formula. I don't know if you want to unmute or if you want to write it down. Yes, you can unmute.
Hi, ma'am.
Hello, Maswiri. Tell me, what is the midpoint formula?
Ma'am, the midpoint formula is x1 plus x2 over 2.
Good, that's the x values, and?
y1 plus y2 over 2.
Beautiful. Don't go away, Shifara, don't go away, because we're going to do something over here. Do you notice how the thing that they've given us at P is actually the answers to the midpoint, right? Yeah. Okay, so if I say to you that we're calculating for the x coordinate, I know that x1 plus x2 over 2 is equal to, what is the answer we need to get out?
y1 plus y2.
What answer would we get out for x? For our x value?
To substitute it.
So if I took my x1 and my x2 and I divided it by 2, what would my answer for the midpoint be?
5, I think.
5, good. So we know that x1 plus x2 over 2 is equal to 5. Right, let's look at the y values. I know that y1 plus y2 over 2 must be equal to what? What is my y value?
1.
Beautiful. They must be equal to 1. That's it. Excellent. But now we're going to put some of these in, right? Shifara, we're going to substitute some of these. I'm going to substitute x1. What value am I going to put in for x1 over there?
4.
4. Beautiful. So I'm going to replace x1 with 4. And then we need to solve for x2, which is the b value for x, right? So I'm just going to take away the x2 part. All right. What about y1? What am I going to replace y1 with?
8.
Think about it. If you replaced x1 with 4, what are you going to replace y1 with?
Oh, ma'am, I couldn't hear your question, ma'am, because my network was...
Oh, no worries, no worries. All right. What are we replacing y1 with?
6.
Beautiful, with 6. Good. So 6 plus y is equal to that. Now we just have to solve for the equation. Yes? It's not that difficult, right? So what am I going to do? How do I get this 2 out of the denominator?
You times it, I think. Times or divide by 2.
Okay, we're not going to divide because it's already divided. So we're going to do the opposite, which is times by 2. Times by 2. And what I do on this side, I must also do on this side. So what I'm going to end up with is 4 plus x is equal to, what's 5 times 2?
25. No, 10.
10, yes, not 5 squared. 5 times 2, good, 10. And then on this side, how do we get rid of the 2 for y?
You times it by 2 again.
We times by 2, and we'd also times by 2 on this side. So these 2 will cancel. And I will get, finish the sentence for me, what will I get?
6 plus y is equal to 1 times 2, 2.
2. Good, excellent. And now we just have to solve for x and y, right? What am I
Yes.
going to do?
You're going to take the 4 over and it's going to become minus.
Good, good, excellent. And what will I do with the 6 over here?
You're also going to take it over the equal sign and it's going to become minus 6.
Beautiful, beautiful, beautiful. All right, good. So my x will then be equal to 10
6.
minus 4,
6,
which is
6
beautiful, 6. And my y value will be?
minus 4.
Yo, Chifaro, you just answered the whole question for the entire class. Just spot on. Beautifully done.
Thank you.
Very nicely done. Ah, love it. All right. Well done, Chifaro. That was very, very nicely done. All right. Oh, my goodness. Okay. Oratile says, ma'am, would you please repeat the whole thing when you're done? All right, Oratile, I'm going to need you to put your hand up so we can unmute you so that, oh, okay. So yeah, I was about to say, wherever it is that we may have lost you, then I need to bring you back from there. Okay, because if we start from the very beginning, then we're kind of doing the same thing over and over and it gets kind of monotonous. All right, give me a thumbs up if the way we solved for the coordinates of B makes sense. Are you guys with me here? Does everybody understand how we found the coordinates of B? Beautiful. And look at that. We were correct. Our X value would be positive and our Y value would be negative. So we did this quite well, right? 6 and negative 4. Okay, Bunta says Y times. All right. Bunta, if I said to you X over 2 is equal to 5, how do we get rid of this 2 in the denominator? Good, we multiply by, yes, Bunke.
Hi, ma'am. How are you?
I'm good, thanks. How are you, my sweetie?
I'm good. Yo, ma'am, like, I'm clearly lost because the way I do it, like, it's way too different. I don't even multiply or anything because, wow.
Okay, so how did you do it, my sweetie? What did you do differently?
What I do differently, I just don't times. The way you did it, it's fine. But, like, for example, the x1 plus the x2, I plus them together, which is 4 plus 5, which gives me 9. And then that's where everything, and then I divide, and then that's where I get my final answer. That's what I actually
What was your final answer?
I didn't solve it like now, but I'm just like way too confused. Why do you actually times?
Okay, all right, my sweetie. So remember, when we're looking for the midpoint, what we're actually doing, Buntle, is we're pretending that they didn't give us the midpoint. Okay, if they didn't give us the midpoint, then your x1 would be those and your y1 would be those values. And down here, you would have x2 and y2, right? So when we are adding them together, Buntle, you're not going to get 4 plus 5 because 5 is the midpoint. You should get that value for x plus this value for x. But we don't know what that value for x is. So your x1 plus x2 is actually 4 plus x.
Okay.
Divided by 2. But what we do know is the answer that we should get out at the end is that our x midpoint value is 5. That's why we took 4 plus x over 2 is equal to 5, because 5 is the end result that we want.
Okay.
Yeah,
okay, it makes much more sense now. Yes.
Do you see why we did the same with y? y1 plus y2, y1 is 6, and our y2 value is y. We don't know what it is, but we know that the end result must be 1.
Okay.
You see that? 6 plus y divided by 2 must equal 1. Okay. Makes sense.
Makes sense. Thank you.
You're very welcome, my sweetie. Keep those questions coming. I love them. All right. Awesome stuff. Okay, cool. Will there be another, etc.? Yes, we're going to do many questions today. All right, we're going to do many questions today, guys. Right, I want us to do B, and then we're going to skip C because it's going to take forever. But we're going to do B very quickly. It says the perimeter of the triangle. And then Buto says, ma'am, why didn't we use any of the other coordinates? Why A? All right, because the question over here says that P is the midpoint of A, B, right? So if we wanted to find B using BC, we couldn't use the midpoint formula. We wouldn't be able to use the midpoint formula because we don't have the midpoint over there. Okay, what we could have used to find B is the distance formula, but the distance formula would give us an X value, and then we'd still have to take that X value, put it back into the distance formula to get a Y value, and it would have taken forever, ever going around and around. So it would have been long. It would have been a long process, but we can use the fact that they've given us the midpoint of A. It wouldn't have worked.
You need to have the distance to find the unknown.
Yes, absolutely. It would never would have worked. Thank you, teacher Nels. Yeah, we wouldn't even have the distance in order for that to work. Yeah, true. Okay, so we can't use C and B and A because they didn't give us any information about C that connects it to B. Okay, does that make sense? All right, excellent. I see that on your screen. Okay, excellent. Yes, Anatida, would you like to answer B for me?
Yes, I would.
Absolutely. All right. What are we going to do? How do we calculate the perimeter, by the way?
Well, we're first going to calculate the lengths of each side of the triangle.
Good. Excellent. Right. So why would we calculate the length of each side? What is the perimeter exactly?
So the perimeter is the right round distance around the shape.
Good. It's the wraparound around it. You like so nicely put. But we know the distance formula, yes? We've seen the distance formula before. What is the distance formula?
Well, it is going to be the distance, which is equals to the square root of x2 plus x1.
Not plus?
Oh yeah,
x2?
sorry, minus x1.
Good. Minus x1.
Close bracket, squared.
Beautiful, squared.
Plus.
Now we can plus. Good. Plus, open bracket.
y2 minus y1. Close bracket, squared.
Good, excellent. All right, so it's going to be a little tedious. Do you agree, Anutida? Because we're going to do the same thing over and over, yeah?
Yeah, it's going to take a while.
Yeah,
this one.
It's going to take a while because we're going to look for the distance of AB, and then we have to find the distance of BC, and then we have to find the distance of AC as well. Okay, so I'm going to give everybody a couple of minutes. Is that okay? And then you can come back and give me the answer that you got. And remember, you must add all of these together when you're done. All right. Yeah. Okay. Excellent. Sure. Anatida, people are even doubting if you're supposed to be in grade 10 because you sound way too smart to be in grade 10. That's a compliment. I love to hear it, actually. Princess, I don't know. Maybe we should investigate. Guys. Whereas like he's a professor, he's a university professor of maths. He's just that good, guys. He's focused. All right, so we're going to use the distance formula, guys. Remember the perimeter is us going around the shape. Okay, we are going around the shape, so we need to calculate the distance here and the distance here and the distance here, and we're going to add all of them up together. Okay. And once you've got that, you can put your favorite emoji in the chat and then we'll continue. All right. You guys have 3 minutes for each because you can calculate it you can punch it into a calculator and it'll give you an answer quite easily. All right. Let's focus, guys. Sinogush is already done. Yeah, while other people are busy investigating whether Anotita is a university professor, Sinoguhle finished. Nice recipe. Okay, Chifaro, you need to find the distance of this side. Find the distance of AB. Use the distance formula. Remember, you get to choose which one is X1. And we're going to call this one X1 and Y1. And we're going to call this X2 and Y2. And then we're going to use the distance formula. And then we can also call this, after you figured out that for BC, you can call this one X1 and Y1. And then for AC, you can switch it around. Call this one X2 and Y2. Okay. Find the distance of each of them separately and then add them together, because that will give us the distance. I mean, sorry, the perimeter. That's what I was aiming at. Ayanda with the bombastic side eye. I was about to ask, is it a hole in one? What is it? It's kind of weird. Ntando's ready to go on holiday. I see you, Ntando. Nkechi. Hi, Nkechi. We know Michael. In fact, everybody's on holiday. I'm just glad to see you guys here, honestly. I'm not gonna lie. I'm just happy that you guys are here. Kelly, I love it when you guys are like, yeah, school is important, ma'am. We must be here. I like the sound of that. I really do. All right, 10 more seconds, guys. It's like, no. Yeah, there's no holidays here. True. Very true, teacher Nows. No, it's not. I thought you liked hanging out with us. Kanti, what's up? How, Chifaro? I thought you had fun hanging out with us. Now all of a sudden you're jiggering. How? Princess. Yeah, I think the holiday has taken over his body, and that's why we're getting all of these kinds of comments here. Agreed. All right, guys, let's have a look at this. All right, pop your answer to the question in the chat, guys. All right, it's kind of tedious because we're going to be doing the same thing over and over again. All right, so we know that the distance between A, B is going to equal to 4 squared minus 6 squared. 4 squared minus 6 squared, or the square root of, my apologies, the square root of 4 minus 6 all squared, which is -2 all squared, plus 6 minus 4 minus -4, which is going to give us 10 all squared. And that's going to give us the square root of 104. Okay, that's the distance of AB. The distance of BC is going to be the square root of 6 minus -4 will give us 10 all squared, plus -4 minus -6 will give us another 10 all squared, right? 10 all squared over there, which is equal to the square root of 200. And then the distance from A to C is going to give us the square root of, let's see, 4 minus -4, that's going to be 8 squared, plus 6 minus -6, that's going to give us 12 squared, which is equal to the square root of 64 plus 144. That should give us 208. 208. Right, so oh, not or, all squared, all squared. All squared. Okay, so yeah, Remufile, no, I'm saying Remufile, the difference is if I said 2 squared, that's just equal to 4. If I said -2 squared, that's equal to -4. But if I say -2 all squared, that's also equal to +4. So when I say all squared, I mean that the -2 is also included. The negative is also included. That's why I say all squared. Okay, I'm not saying all squared, I'm saying all squared. I hope that makes sense. Okay. It's not that I'm saying all squared. Okay. Okay. Caitlin says, ma'am, can you do BC again? Absolutely. I'm going to get 6 for my X values. I will get 6 minus -4. -4 all squared. And that's 6 minus -4 will give me +10 all squared. Plus, and then I'm going to get -4 minus -6. Ah, thank you. Thank you, Caitlin. I actually did make a mistake there. I just realized. 6 minus -4, this would be 2 all squared. Thank you. Thank you, Caitlin. Thank you for picking that up. You see, I was testing you and you passed. And you passed. Well done. Well done, Caitlin. Good. It's +2, so that should give us 104 again. That should give us 104. Okay, excellent. And now I have to check all my other answers, make sure I didn't make a mistake anywhere else. 4 minus -4 will give us 8, and 6 minus -6 will give us 12. All right, so the rest of them are all correct. So remember, guys, we need to add them all together. So we're going to go the square root of 104 plus the square root of 4 plus the square root of 208. Right. What answer do we get, guys? Punch your answer in the chat for me. I'm thinking you should get something like 4 root 104 or something crazy like that. There'll still be a number under the square root. Sure, it's a crazy number. All right, we're going to leave it to 2 decimal places. So your perimeter should be 34,81. Units. Thank you, Teacher Nels. That's correct. That's okay, Oratilo. It's going to be correct as long as you use the formula correctly. Okay. Hi, Didi.
Ma'am, like I think I made a mistake. The first time by distance BC wrote 10 in the brackets, and then you got the square root of 200. So ma'am, like I got the same thing, but then you then changed it to 2, and then you wrote
Yes,
104.
okay.
So I'm not sure what happened there. Yeah, I might have made a mistake somewhere.
I'll explain to you because Caitlin just pointed it out. Okay, so if we do the distance of BC, we're going to get 6 minus, because that's x2 minus x1. That's going to give us -4. Agreed? That's all squared. Plus, our y2 value is -4 minus -6. All squared. right? We're still together. Now, 6 minus negative 4 gives us 10 squared plus negative 4 minus negative 6. That's plus 6. So negative 4 plus 6 will give us positive 2 squared.
Okay.
So that's where we get the 10 squared. I made the same mistake and Caitlin actually caught me. So,
okay, thank you.
sure.
Thank you, Caitlin.
Thank you. I think you're thanking the right person now. It's not ma'am, it's Caitlin. Caitlin, I mean, I feel like you're gonna steal my job, so maybe they shouldn't be thanking you too much. But thank you, Caitlin. All right, guys. Excellent. All right, let's look at this next question. I can show how we got AB very quickly, my sweetie. My x2 value is 4 minus negative 6 all squared plus 6. Did I do it wrong again this time? No, I didn't. I did it correctly. Yeah, minus 6 minus negative 4 all squared. 4 minus negative 6 is 4 plus 6, which is 10 squared, plus 6 minus negative 4 is 6 plus 4, which is also 10 squared. The square root of all of that, that's 10 squared plus 10 squared is equal to the square root of 100 plus 100, which is 200. Okay. I'm lying. This is 4 minus 6. Yo, teacher Coco. This should be negative 2 all squared. Okay, there we go. I know. I feel it. She's like, look at me, look at me. I'm the captain now. I see her. I see Caitlin. All right, guys, let's look at this next question over here. Okay, it says here that SUVT is a parallelogram. What do we know about parallelograms? What do we know about parallelograms? You can pop your properties of a parallelogram in the chat. Diagonals bisect, good. Anotita, opposite sides are equal, good. So we know that SU is equal to TV. We also know because they are equal, we know that ST is equal to UV. We also know that where they bisect right here in the middle, we know that this point right here will be our what? Good, opposite angles are equal. This point right here in the middle will be our, not just an intercept, it's the midpoint. Good, it should be the midpoint of both the lines that we're looking for. Good, it's the midpoint of both. Right, now I want you guys to look here. They say SUVT is a parallelogram with vertices S, T, U, and V. Do you guys notice they have not given us V? They have not given us the values for V. They haven't given us X and Y. So they say, find the coordinates of V by using the fact that the diagonals of a parallelogram bisect each other. And that's the important part. We know that exactly where they bisect, that is the midpoint. Who has any clue? What can we possibly do to figure this out? Didi, what do you think?
Ma'am, we're going to use a formula for midpoint for T and U. And then from then on, we're going to use the midpoint again to find the V using S and M. I mean, like the point where it bisects.
Yeah. Beautiful. Beautiful. We're first going to find step one, because Didi, I feel like Didi and Caitlin, you guys are very dangerous. Number one, find the midpoint of TU. Find the midpoint of TU. And then once you found the midpoint of TU, we know that the midpoint of TU is equal to the midpoint of SV. So if we have the midpoint of SV, we can use that first thing that we did at the very beginning of the class, where we went x1 plus x2 over 2 is equal to the x value of the midpoint, and y1 plus y2 y1 plus y2 over 2 is equal to the y value of the midpoint. That's the second thing we're going to do. So we can use both of those things, okay, to do these. Oh, yes, thank you, teacher Nels. There is a difference between midpoint theorem and midpoint formula. Thank you. I hadn't actually noticed that Mbalenka had written midpoint theorem and not formula. All right, let's say Pile, be very careful. Midpoint theorem is something completely different to the formula. All right, everybody's got exactly 3 minutes. Pop your favorite emoji in the chat once you've found the coordinates of V. Yes. Michael's asking, does y equal -2? I don't know. Which y? Which y? I can tell you the coordinates of t over here are -2 and -1. So you guys can take that where you will. Sipokazi, not Sipokazi being a whole red flag. I can't. All right. Thank you, Princess. Oh, I love some of these emojis. Okay, so Michael's saying that he's given us the answers. We'll see. Michael, we are yet to see if your answers are correct, in fact. Okay. 1.5 more minutes. Nice emoji, Balente. I love that one. I use it all the time by default because every time I type cool, it's the first thing that comes up. So I just click on it and I send. Chifaro's making everybody hungry. I don't like you right now, Chifaro. I haven't had dinner. Nice one, Caitlin. Nice one, Amakelang. Oh, Michael, is that your emoji? Lol. Lol is not an emoji, my guy. You must pick an actual emoji. Nice one. All right, guys, that's time. How? Didi, is that I don't understand, or is that your emoji? Oh, you guys are confusing me. All right, let's have a look, guys. Let's calculate very quickly for the midpoint of TU. All right, so the midpoint of TU, oh, that's okay, my sweetie. We're going to look at it now. Right, the midpoint of TU, my x1, we're just going to pick one, x1 and y1. And this is x2 and y2. My x1 is -2 plus 2 over 2. And my y1 will be -1 plus 0 over 2, my y1 and my y2. And this is going to tell me that the midpoint of TU is equal to 0 and -0.5. Right. So the midpoint of TU is also the midpoint of SV. So we know that the x value of SV goes here and the y value of xv goes there. And that's how we find the values of, that's how we find the values of v. So we're going to name them again. We're going to name this one x1 and y1, and we're going to name this one x2 and y2. Ah, okay. You are right on point. Well done. Well done, Didi. That's so awesome to see. All right, so we know that our x1 is -1, -1, plus our x2 is x, we don't know what it is, over 2 is equal to 0. And then our y1 is equal to 2, plus our y2, which is y, over 2 must equal to -0.5. Right, and then we can just multiply each of them by 2 times by 2 times by 2. Those 2 cancel, times this side by 2 times this side by 2. Those 2's will cancel, those 2's will cancel. I will have -1 plus x is equal to 0. And on this side, I will have 2 plus y is equal to -0.5 times 2 is -1. Right, so these are the values for v. V will then be equal to, I'm going to take the -1 over to the other side, will become +1, therefore x is equal to 1. And the 2 will go over and become -2. So my y value will be -1 minus 2 is -3. All right, give me a thumbs up if you got the correct answer. V is 1 and -3. Those are my two values. Let me know if you got the correct answer over there.